Hello, I'm Seema and welcome to part 27 of the chapter Organic Chemistry, Some Basic Principles and Techniques. The topic of this video is resonance effect or mesomeric effect. In the previous video, we were talking about resonance structures and you learned how to make resonance structures. Before I explain this, I would like to take you to the fourth chapter where we did chemical bonding and molecular structure. And I told you about covalent bonds. You remember a covalent bond is a shared pair of electrons. A shared pair of electrons between two atoms. And each atom contributes one electron. And this pair of electrons is equally shared by both the atoms. But if one of these atoms is a little more electronegative, the bond tends to be polar. That is, the electrons shift more towards the electronegative atom and it can result in the polarity of the bond. Anyway, this shared pair of electrons, I also told you about sigma bonds and pi bonds. The first bond that is formed between two atoms is a sigma bond. It is formed by the head-on overlap of the orbital. If it is the p orbital, the px will overlap, or pz will overlap head-on. That is, directly it'll overlap on the head. I mean, the impact would be directly on the head and the bond would be formed. So the first bond that is formed is very strong, it's very stable, and usually breaking this first bond or the sigma bond is not easy. The second bond may be formed by the sideways overlap of the orbitals. That is, if it is a p orbital, it will be in the shape of a dumbbell. So if you take these as two dumbbells, then sideways the orbitals overlap. This kind of an orbital overlap is not that effective. Therefore, this second bond that is formed is not as stable. Why am I telling you this? Because this second bond that is formed, the electrons, a bond is just a pair of electrons. So the electrons that are present in this second bond, they tend to not be so strongly bound and there is a possibility for them to move. Similarly, in some atoms, we also find that there may be lone pair of electrons which are present in the molecule. Now, these atoms which have lone pairs of electrons, the lone pair is always available and it can move or it can delocalize. Movement means it has a location and it can move from its location. So we say a delocalization of those electrons is possible. In certain organic molecules, where there is a conjugated system, that is when you have single and double bonds alternatingly. Or you have single and instead of double bond you have an atom which has lone pair of electrons. In other words, you have a system in which there is a possibility of one sigma bond and one pi bond alternating, or electrons which are whom it is possible to delocalize them. So such loose electrons, either in the form of lone pairs or in the form of pi electrons, when you have a system, a molecule in which you have these in an alternating sequence, such a system is known as a conjugated system. And why is the conjugated system so important? Because in a conjugated system, when delocalization occurs, when pi electrons or when pi electrons or lone pair of electrons move from their position to the adjacent atom, then the next atom also has a double bond or it also has a lone pair of electrons. As a result of this electron movement towards it, these electrons will experience repulsion and they will move away from it. So they would also get delocalized. And when they get delocalized, the next bond is a single bond, so they can go there. But the next bond is again a double bond or there is a lone pair. So that gets affected by these and that moves further. So what happens? A chain reaction starts. That as delocalization occurs at one step, it is carried on in the chain. It is carried forward in the chain. And such an effect of delocalization of pi electrons or lone pairs of electrons in a conjugated system is known as resonance, right? And this is known as the resonance effect. So let me just read this. What is resonance effect, or it is also known as mesomeric effect? It is defined as the polarity. Oh yes, this is very important, the word polarity. You know, when electrons move, let us say from one atom, they move away, or when there is a pi bond which has two electrons, then those two electrons belong to, let us say here, the second bond. The second bond, one electron belongs to this carbon and one electron belongs to this carbon. When these two electrons move to the next bond, then one electron of this carbon is lost. And although it forms a bond on this side for this carbon, it still has its own electron, but this carbon has lost its electron. Therefore, this carbon becomes positively charged. And wherever the electrons move, that becomes the negatively charged atom. Because now when it moves this side, the extra electron that has come in belonged to this carbon. It did not belong to either this or this. Therefore, it will have a negative charge. So, a movement, a polarity is created. What is polarity? Positive and negative charges are created, or terminals are created in the molecule. So, what is resonance effect? It is defined as the polarity which is produced in the molecule by the interaction of two pi bonds. These two pi bonds are interacting. Why do we say two pi bonds are interacting? Because this pi bond, if it moves here, this pi bond should move further. Right? So it is an interaction between the pi bonds, two pi bonds, or between a pi bond and a lone pair of electrons. For example, in this case, you have nitrogen and aniline. Nitrogen has a lone pair of electrons. That lone pair of electrons will participate in resonance. So it is the interaction of two pi bonds or between a pi bond and a lone pair of electrons which is present on an adjacent atom. This would only be possible if every alternating bond is either a double bond, single bond. Every alternating bond should be similar. The presence of alternate, single and double bonds in an open chain or a cyclic system will lead to resonance. And such a system where you have alternating single and double bonds, whether it is in an open chain compound or it is in a cyclic compound, such a system is known as conjugated system. And all molecules that have this conjugated system, they show abnormal behavior. And what is that abnormal behavior? That abnormal behavior is the delocalization of electrons. So what do we see if we notice this delocalization, let us say in benzene or in any of these compounds where we notice a conjugated system? The electrons, they move into the system, and the adjacent electrons, if let us say two electrons came here, the next two electrons move further, they move further in a ring, they move further, and they come back to the same point. So what do we notice? That electrons are actually dancing between the entire molecule. They are free, they seem to be floating around in the molecule. And that is an abnormal behavior. It's not normal, because when we say bond, we imagine fixed electrons between two atoms. But here, the pi electrons are not fixed, they become delocalized, they move around, and that is the abnormal behavior which is known as resonance or mesomeric effect. Resonance effect or mesomeric effect. Now, all these resonance structures, the structures that you learn to make in part 26, I would encourage you to watch that video once again so that you know how these electrons move and how you understand the movement of electrons in resonance. Examples of compounds that may show resonance would be aniline. In aniline, take a look, nitrogen has a lone pair of electrons, then there is a single bond, then there's a double bond, single bond, double bond, single bond, double bond, single bond, and then you again have here nitrogen which has the lone pair of electrons, which if it comes here, it becomes a double bond. So this is a conjugated system in which the resonance can take place. Similarly, 1,3-butadiene. 1,3, the first carbon and the third carbon have got double bonds. It is butane, that is 4 carbons, diene, there are 2 enes, 2 double bonds. So 1,3-butadiene is also a conjugated system. Aniline is a conjugated system. Nitrobenzene is a conjugated system. In nitrobenzene, again take a look, you have nitrogen here and you have the ring. But this is different from aniline, and when I explain the structures, you'll understand why this is different. But still, these are systems where you have conjugated, these are conjugated systems which show resonance structures. In such systems, the pi electrons are delocalized. I just explained this to you, that the pi electrons, they get delocalized, they move from their locations, and the system develops a polarity. I also explained why would the system develop polarity. Now when we do these examples, you'll understand it again. There are two types of resonance effects. The two types of resonance effects, how would they be created? There would be one possibility that electrons are being pushed into the ring or into the resonance. The resonance is taking place where electrons are moving around, or the negative charge is revolving. There is also a possibility of resonance which will also occur due to electrons, movement of electrons, but this results in the movement of positive charge instead of negative charge. Therefore, the resonance effect has been classified into two categories, plus R effect and minus R effect. When I say plus R, it does not mean positive charge. Plus means that addition. In this case, I would want you to memorize it in this way, that it is addition of electrons. Okay, so positive resonance effect, how do we define it? It is, in this effect, the transfer of electrons is away from the atom or the substituent group. If whatever atom is there, like nitrogen, which has a lone pair of electrons or whatever, if it gives electrons, it is providing electrons, it provides a negative charge. Itself, it becomes positively charged. And then this negative charge is transferred and takes place, that causes the resonance. Such an effect is known as the plus R effect. Addition of negative charge or electrons is taking place. So addition would be the plus. So the electrons are moving away from the substituent group, which is attached to the conjugated system. And as a result of this, the electrons, that is the negative charge, rotates. This electron displacement makes certain positions in the molecule of high electron density. Certain positions of the molecule, they become high in electron density or they acquire negative charge. Example of plus R effect is aniline. In this compound, take a look, you have a benzene ring with nitrogen H2, and in aniline, nitrogen is forming only one bond. We know one bond here and two bonds with hydrogens. Nitrogen has a lone pair of electrons. Now we know that nitrogen has 5 electrons in its outermost shell. It is the 7th element, right? Since it has 5 electrons in its outermost shell, it forms 3 bonds and it has 1 lone pair of electrons. So in aniline, we see that the nitrogen has a lone pair of electrons. It forms 2 bonds with 2 hydrogens and 1 bond with the benzene ring. Now, this lone pair of electrons that is present on nitrogen, it can be available for resonance. So this lone pair, it comes down here and forms a double bond. When it forms a double bond here, what happens as a result of that? As soon as a double bond is formed, this carbon, now we know that every carbon can form only 4 bonds. Now this carbon here is forming 2 bonds here, 1 bond with this carbon and 1 bond with nitrogen. So if this lone pair forms a double bond here, then this carbon is forming 5 bonds, which is unstable. It cannot be stable if it forms 5 bonds. It is exceeding its octet. So what happens, as soon as the pi electrons, they come here and they form a double bond, this pi bond is forced to move away because the electron density is very high and the octet is being disturbed. It leads to instability and this pair of electrons moves to the next carbon. And when this pair of electrons moves to the next carbon, what do you mean by a pi bond? It means both the carbons were contributing 1 electron each, but both the electrons of both the carbons have moved to this carbon. Therefore, this carbon becomes negatively charged, single negative charge. 1 electron was its own, but 1 electron belongs to this carbon. Therefore, it acquires a negative charge. As soon as negative charge is created on this carbon, the problem comes with the adjacent bond. Now, in order to neutralize it, the pi electrons will move to the next carbon and allow the pi electrons to form a bond here. So this lone pair, it has now become a lone pair. This lone pair of electrons will shift to the next bond and it will form a double bond here, while at the same time the same situation arises and the electrons of this bond will come here and the negative charge will be on this carbon, the 4th carbon on the opposite side. Now you see, nitrogen had started this reaction, it had started this process, and this process is now being transferred to the next bond, it is being carried over. It is as if, in a cycle stand, you hit one cycle, and they are all standing like adjacent. You hit one cycle and all of them tap, 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 they fall down. So once the effect is started in one direction, it kind of, in a conjugated system, it is carried over throughout the molecule. So the negative charge comes here. The same situation, this lone pair of electrons will move here to form a bond here, and this bond will be forced to form a negative charge here. And in the next step, what will happen? This lone pair will form a bond here, and as soon as it forms a bond here, the lone pair from nitrogen who had formed a bond here will go back to nitrogen, and you will get back the structure, only the 3 bonds will be in different positions. But basically it's the same structure. So we find that these are the resonance structures, or this is how resonance effect took place. And these were the resonance structures which were formed. Now, which are the substituents which would result in a plus R effect, or positive resonance effect? Plus R effect will only be produced by those substituents who can provide electrons, who can push electrons away from themselves. Okay? And they will cause the electron, that is the negative charge, to rotate in the molecule. Such species which show plus R effect are halogens, because halogens, they will all be species where directly to the carbon you will have an atom which has a lone pair of electrons. You will notice in all of these there will be atoms which have a lone pair of electrons to initially trigger the chain reaction. Just as in the case of aniline. See, if you have halogens, a halogen attached, all halogens have lone pairs of electrons, so they are in perfect position to start this reaction by giving one lone pair of electrons, forming a double bond, and then it carries on. OH, oxygen, would have lone pairs. Oxygen, OR, where oxygen is directly connected to, R means carbon, it would be connected to a methyl group, so it is attached to carbon, and on the other hand it is attached either to the ring or the chain. Again, here you have OC, here also. In OR also, oxygen is attached to carbon, and in OCOR, again, this oxygen can provide the lone pair of electrons. In NH2, which we just saw, nitrogen has the lone pair of electrons. In NHR, again, you will have nitrogen would have lone pair of electrons. NR2, that is all the amines. NR2, they would also provide, and NHCOR would also have a lone pair of electrons on nitrogen. So all of these groups or substituents are the ones where the atom that is directly attached to the carbon of the chain in the conjugated system, to the atom which is of the conjugated system, have got a lone pair of electrons to provide that pair of electrons. And once that is done, the effect would be positive R, which means positive means addition of electrons. So negative charge will rotate. Negative resonance effect would be the opposite. Negative resonance effect means sucking out the electrons. You have a group which is attached, which instead of giving electrons to the system is going to take away electrons from the system. The effect is going to be the same. Whether you push electrons and force the next bond to move away from it, if you suck electrons away, the opposite happens. The adjacent bond will try to come towards you in order to remove the deficiency or to help fulfill it. So negative resonance effect is when the transfer of electrons takes place towards the substituent, not away from it. So it would be an electron deficient group, a group that will kind of pull the electrons towards itself. For example, nitrobenzene. Now you would say, amine also has nitrogen and nitrobenzene also has nitrogen. It doesn't make sense. And she just said that nitrogen has a lone pair of electrons here. So why is nitro also not acting, showing plus R effect? The reason here is that nitrogen, take a look here, nitrogen has 5 electrons in its outermost shell. It usually forms 3 bonds and 1 lone pair of electrons it has. But in this case, nitrogen is forming 3 bonds, 2 with oxygen, 1 with carbon. It has already formed its 3 bonds. And this lone pair of electrons that it had is being used to make, do you see this arrow? It is this lone pair of electrons which belongs to nitrogen which is causing this bond to be formed. So this bond is not a covalent bond, it is a coordinate bond. A coordinate bond, what is a coordinate bond? A coordinate bond is a bond which is, practically it is a covalent bond, it is a shared pair of electrons, but in this shared pair of electrons, the contributor of those electrons is only one atom. Both atoms do not contribute. It is a bond, it is a shared pair of electrons, but one of the atoms contributes the electrons. So as a result of what happens? Nitrogen, its lone pair of electrons is already busy in forming a bond with oxygen. Therefore, this lone pair of electrons cannot be thrown into the ring to participate. Now you would say, come on, this oxygen has got two lone pairs. Why is this not participating? The reason for that is that it is not connected directly to the conjugated system. It is not connected to this carbon. If the atom which is directly connected to carbon should have been the one having the lone pair of electrons. If the atom next to it has lone pair of electrons, those electrons are not available to be added to the chain. They would not be electrons that would be added to the chain. And plus there is a double bond here already. So even if they tried, they cannot come here and form a triple bond. That would energetically be impractical. Right? So what do we find here? That in the nitro compound, in nitrobenzene, benzene and nitrogen is attached to it. This is a coordinate bond and there's a double bond with this oxygen. So this pi electrons, the pi electrons of nitrogen and oxygen, this pair of electrons moves towards oxygen. When it moves towards oxygen, it makes oxygen negatively charged. And when it makes oxygen negatively charged, what happens? Immediately, the pi electrons here rush to help. And when they rush to help, the two electrons here, they shift here and form a double bond with nitrogen. And now since this double bond or this pi bond was formed as a result of a shared pair of electrons between this carbon and this carbon, and the entire bond has moved, it means the electron of this carbon has been lost to that bond. Therefore, this carbon becomes positively charged. So what did we see? That instead of here, what had we noticed? Negative charge was revolving all around. It was negative charge. That's why we called it plus R effect, that it was adding electrons to the entire molecule. But here we call it minus R because it has the resonance is occurring as a result of sucking away electrons and resulting in the movement of positive charge. So positive charge is created here. As soon as positive charge is created here, the same situation arises. The pi electrons in the adjacent bond, they rush to help it out. And when they rush to help it out, this carbon loses its electron and it becomes positively charged. And when this electron becomes positively charged, the same thing, this pi electrons, the pair, it rushes to help it out. And when it rushes here, it forms a double bond here, but this carbon has lost its electron, therefore it becomes positively charged. In the next step, what will happen? The double bond will come back here in order to help this, and the positive charge will go back up, and oxygen will be forced to give back the electrons that it had so selfishly taken in the pi bond, and therefore you will get back the first compound or the first structure. So this was negative resonance effect. So all those substituents who will have a tendency to pull electrons towards itself, which means that they would have an atom which is kind of electron deficient, or it has a lot of commitment on its sides, and therefore it has a tendency to pull electrons towards itself, or the atom adjacent to it can pull the electrons, as was in the case of this oxygen, who could pull the pi electrons towards itself and result in the negative resonance effect. Such groups would be COOH group, that is carboxylic acid, aldehyde, CO, CN, and NO2. NO2 we've already seen, right? So this was resonance effect. Resonance effect is also known as mesomeric effect. So that would be it about resonance effect. With this, I will wind up today's video. If you found it helpful, please give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.